Hey, time to get started again. Shilpa, are you ready to go? What I had in mind is to do a few more practice problems. Is that okay? Before we start with hydrology and hydraulics. These problems are probably a little bit easier than some of the problems we did earlier. The first one we already did, some of the moments about the hinge point. Let's look at problem 45. Here's a pitot tube. The manometer level here is higher for the pitot entrance than for the static port. So based on this value for H, we can normally figure out the velocity. Here it's just the opposite. We know somehow the velocity, and we're asked to determine what the corresponding deflection is, H, the reading. If 1 is the entrance of the pitot, and then 2 is the location corresponding to the piezometer, the static port, we can apply Bernoulli between 1 and 2. P1 over gamma plus Z1 plus V1 square over 2G is P2 over gamma plus Z2 plus V2 squared over 2G. What stuff cancels here? Shilpa, what term cancels? Difficult to answer if you have to type this. If we have a horizontal pipe, the Z's cancel. And then inside the pitot, there's no flow, so V1 is going to be equal to 0. So we have P1 over gamma. Yeah, the head associated with the stagnation point is equal to P2 over gamma, the static head, plus V2 squared over 2G, the dynamic head or velocity head. Then from manometry, we know that the pressure here needs to be the same on both sides. Let's call this A and here B. So we can blow this up a little bit otherwise. So PA is PB. We also know that PA is equal to P1 minus gamma Y, if Y is the difference between the center of the pipe and the upper manometer surface. And same story for B. PB is P2. Now the pressure at B is going to be less than 2. We need to subtract gamma Y minus H. We reach this surface. And then we assume that the specific weight of air is so small the pressure doesn't change in the air phase. Gamma air is equal to 0. Since PA is PB, we must have P1 minus gamma Y is P2 minus gamma Y minus H. The gamma Y cancels and P1 minus P2 is equal to gamma H. How do we find P1 minus P2? From the velocity head. So then if you work that out, P1 minus P2 gamma is going to be equal to 2 squared divided by 2 times 9.81. It's going to be 0.2. So answer D is the correct one. Yeah, any questions? Let's go to the next one. Density is given, specific gravity is given. We need to figure out the kinematic viscosity, which is really mu divided by rho. One and a half is the relatively large dynamic viscosity. What is rho? Yeah, what value? It's a little bit of a trick question. .263 times the density of water is 1.188 times 10 to the minus 3. So we have C as the correct answer. Because the specific gravity is the density of our fluid divided by the density of water, or if you like, the specific weight. So rho is 1.263 times the density of water. Yeah, I know you want to answer quickly, but make sure you understand what fluid we're talking about. Let's go to the next problem. Archimedes principle. The buoyant force is the specific weight times the displaced volume. So if you have some object that is floating in, say, water, there's a buoyancy force, F the buoy, and there is the weight of the object, W. Those are equal. Gamma, what does that refer to? Gamma is rho times G, specific weight. Is it the specific weight of the fluid or the object? No. Of the fluid.